Hello everyone. So today we are going to solve Leet code problem number 46, which is permutations. So let's understand what we need to do here. So here we are given an integer array. So we are given an integer array 2 and 3. So in this problem we need to print all the permutations for this array. So what are the different permutations for this array? Now if you look at the size of this array is 3. So if we need to find all the different permutation for an array of size 3, what are the total number of permutation? It's always 3 times 2 times 1, which is equal to 6, which is nothing but it is n factorial. Okay, so these are the different permutations that are possible for this. Now if we print all the permutation of this, so we will have 1, 2 and 3. Then I'm going to have 1 and I'm going to exchange this to position for 2 and 3. So 1, 3 and 2. And now I'm going to have in this first position 2. And here I can have 1, 3 and then 2, and here I can have 3 and 1. Now in the first position I'll have 3. So here I can have 2 and 1. I can have 1 and 2. So there are total 6 permutations. Now how can we do that? So if you look at this example, what I have done here is I just took this first position and replace it with 1, then replace it with 2, and then replace it with 3, right? Same thing for the second position. I replace it with 1, then 2, then 3, and same with the third position. Replace with 3, 2 and 1. Okay, so what we can do here is I can start with the position 0. So let's consider that I'm storing that with my left pointer. My left pointer is pointing here at 1. So I'm starting at position 0. Then what I'm doing is I'm iterating through all this element and I'm replacing them. I'm swapping them with the element which is at position 0. So if I do that, right, if I swap position 0 with position 1, what do I get? 2, 1 and 3. Another swap that I can do is I can swap my position 0 with position 2. So I'm swapping this both element. If I do that, I get 3, 2, 1. Okay. So now what I'm going to do is, and I also swap with the number itself. And let's see, if I swap with my own number itself with 1. So I'm swapping position 0 with 0. So I get 1, 2 and 3. Alright. So now what I'm going to do is, now I'm going to move on to my position 2. So I'm going to increment left here. Now it's going to be 1. Now in this case, what I'm going to do is, my left pointer is pointing here, and I'm going to swap this 1 with itself and then 1 with 3. So I'm going to do the swapping for the second position with this 2 element. Okay, so if I do this, if I swap my position which is left with 1 with that 1, I get 2, 1 and 3. But if I swap my position 1 with 2, I get 2, 3 and 1. Same thing I'm going to do here. Here also my left is 1. Okay, and I'm going to swap. So if I swap 1, 1, so I'm doing swapping 2 with itself. So I get 3, 2, 1. Then I'm swapping my left position with 2. So I'm swapping this both element, and what I get is 3, 1 and 2. So now same thing I'm going to do with this one. So I'm going to swap 1 with 1, and what I get is 1, 2 and 3. But when I swap 1 with 2, I get 1, 3 and 2, right? Now again I'm going to increment my left pointer, so my left pointer will be equal to 2. So that is the last element. There are no more element to swap with, right? We cannot swap this element with no more element left on its right, so we cannot swap this element with any other element. I mean, swapping this element with itself is gonna result in the same permutation, so no need to do this. So we can do this till length minus the length of that array minus 1. Okay, so these are all the permutation. If you look here, these are the permutations starting with 1, where I have 1 in the first position, then in this permutation I have 2 in the first position, and then this. So these are the same permutation that I have written above, right? So this is the simple thing that you can do. Now if you notice here, okay, when I was doing this swapping thing, right, when I performed the swap, so this was my initial array. When I performed the swap, my array became this, right? And then I made a recursive call. I did this too and whatever. And after I'm done with all of this processing below this, and when I come back here, right, I have to go back to the same array. I need to change my array back. So I'm going to unswap this. I'm going to do this unswap. So I can get this array, and then I'm going to do again perform this swap. So this is you can write this code for this using a recursion. And if you look here, okay, so here what we are doing is the tree. The height of the tree is the size of the array. But then if you look at the branches of the tree, it's like first we have 3 branches, then we have 2 branches, and then we might have 1 branches, right? 3, 2, 1. So if you look at the time complexity, it is n factorial. And if you look at the space complexity is O of n, which is the height of the tree. So now if you go and write the code here, your recursive function, okay, it's going to take this array, which is an integer array. Then we are going to pass the left position, which is going to start with 0 at first. And what else we are going to do? Nothing, that's it, right? So what is our base case for this recursive function? So we are stopping our processing when this left position is equal to size of array minus 1. So if left position is equal to a dot length minus 1, we are stopping our procedure, I mean the recursive call. So in this case, this array will have that permutation, so we can print or save or whatever you can do, we can print the array or whatever. So that's our base case. But if we are not in the base case, then what we are doing is we are swapping every other element that we have, including the element at the left position, to all the way to its right, or we are swapping all the element with the element in the left position, and then we are making a recursive call. So what I'm doing is I'm performing a swap, and I'm performing a swap in this array with the left position, and then I'm performing the swap. So I need to write a for loop because I'm performing the swap for all these elements. So I'm performing for 1 and 3. I'm swapping 1 with itself, then I'm swapping 1 with 3. So whatever the left position, I need to iterate from left position till the length of the array, right? So for integer I is equal to left position and I is less than a dot length I plus plus, and I'm performing the swap with I'm swapping the element at the left position with the ith element, and then when I'm done with the swap, right? So here I swap this element at 0th position with itself. So here I swap the element at 0th position with itself. So and here I swap the element in the 0th position with 1, and then I swap the element at 0th position with 2. So when I'm done with the swap, I'm going to get this array. For example, if I'm swapping the element at 0th position with the element at the first position, I'm going to get 2, 1, 3. My array will be like this. Then what I'm doing is I'm repeating the same step again. So I'm going to call the same recursive function again. So I'm going to call my function with the array, but this time I'm going to increment my left position plus 1. Why? I don't care about I. So just the left position. Okay. And why I'm incrementing my left position? Because I have already performed the swap on the left position. So I have already performed, here left was 1. I already performed a swap at this position. So here the left was 0. So I swapped this 0th element with this element. So I swapped this 2 element and I got 2, 1, 3. Right now here left was 0. Then I incremented my left to 1. Okay. So now I'm not going to perform the swap for the first 0th position, but now I'm going to do for the first position. So then I have incremented my left, make a recursive call. Now after I am done with this recursive call, whatever underneath is, whatever it is, after I am done with whole this branch of a tree, and when I come back, okay, from that recursive call, at that point I need to unswap. I need to change this array 2 1 3 to the original array 1 2 3. And how can I do that? I can again perform the swap, which is actually an unswap with the same two element, left position and I. So closing the for loop, closing the else, and closing the main function. So here our TC is n factorial and our SC is O of n. Okay. So this way we can print all the permutations. Okay. So let's write the code in the Leet code. I have already written a code, so what I'm gonna do is I'm gonna reset it. Let's reset, and then let's write the code again. Okay, so we need to return, we are not printing our result, we are not printing the permutation. So here I showed you that you can print the permutation as out as system.out.println. You can print it, but here we don't need to print it. We need to return it as a list of list. So here it's a list of list with all the permutations. This is how we need to return. So what I'm going to do is first I'm going to initialize my result list integer result is equal to new array list. Once I'm done with that, I need to write a recursive function. So I'm going to write a recursive function that helps me to find the permutation. So permutation helper function, which is a recursive function. This function is going to take a left position that's going to start at 0. It's going to take an array, the given array, and then the result where I'm going to store my result. And then at the last, I need to return my result, which has all the permutation. Okay. So now public, and this is returning void. We don't need to return anything. Permutation helper, and this is my left position, this is my array, and this is my placeholder for storing my permutation. Okay. Okay, so now what is our base case? So if the left position is pointing to the last element, we don't need to perform a swap. We can perform a swap, but it's irrelevant. So it's equal to nums dot length minus 1. And what we are going to do is, our array has the permutation, so we're gonna iterate. We need to list of integer permutation is equal to new array list. Now we are going to iterate our array, and then we are going to add this to this, and we are going to add this to the result, our permutation list that has the permutation, and that's it. Else we are going to perform a swap in our array with the left position and the ith position. We need to have a for loop here that iterates from the left position to the last second position, because at the last position we are performing swap with itself, which is not needed. So I is equal to less than nums dot length minus 1 I plus plus. Or we can just perform a swap. It's not needed, but or I less than nums I less than nums dot length. So that if the length of the array is 3, we are going to iterate from the left position. We need to iterate through all the way, through all the element in the right. Okay, so left position, from left position to the last element. Here we need to iterate through all the elements, and then we are going to perform our swap. Here in the for loop. After we are done with the swap, we are going to make a recursive call to the function permutation helper. But now this time the left position is plus 1. We have our nums array and we have our result array. And then again we're gonna do the unswap. Okay, and we are done. Let's write the swap function. This is the ith position, this is the jth position. We're going to swap both the elements. So integer temp is equal to nums of I is equal to nums of j, and nums of j is equal to temp. That's our swap function. So did I miss anything? Looks like a correct code, right? Yeah, it looks correct. Let's run. Okay, I'm going to run my code. Okay, what is the error? Is equal to if, oh, I'm sorry, left position is equal to nums dot length minus 1. That means our left position is at the last element. No need to perform any further swap and making a recursive call. So we are done at that point, and let's see what happened to our result. And yes, it got accepted. Let me submit it and let's see if it passes all the test cases. Then yes, it did pass all the test cases. So this is a case of a recursive solution for finding the permutation of a string. You can, if you are given a string A, B, C and you need to find the permutation, you can convert it to the character array and write the same code that I have written here. So that's it for today. Thank you so much.